The way we achieve the improved student learning outcomes is based on these two fundamental ideas. The first, that we can take learning science and derive design principles around which we can build highly effective outcomes-focused courseware. And the second is that we can gather, model, and use learning data in effective ways to continuously improve and optimize student performance. By learning science-based design, I'm just going to give you a few simple examples and show you one page of a course where you can see some of these principles at work. But these are fairly straightforward principles. The student benefit from knowing what their goals are and having clear learning goals in advance. They benefit from learning by doing as opposed to being passive learners. They benefit from practicing frequently and getting feedback targeted at the mistakes that they're making. And they benefit from being able to synthesize and apply new knowledge as quickly and as often as possible. I'm going to show you one simple page again to just show you what a few of those principles look like at work. This is a introduction to biology course that we've built. There are 5 core competencies in the course. This is a data dashboard in addition to a navigation device. Students can actually see what the core competencies are and then drill down to see each of those core competencies, what building blocks make those up, and what their learning progress is. But I want to focus for a moment on just taking you into the course itself. Our courses are made up of units. Units are made up of modules, and modules are built around learning outcomes. In this particular module in mitosis, the 2 key learning outcomes are to be able to describe the stages of the cell cycle and explain the roles of mitosis and meiosis. We're going to go to Module 20 on mitosis, and I'm going to start by just showing you where we are here again in the course. And so we have here Unit 6 on cell division. We have a module on mitosis, and mitosis is made up of the following key topics, each topic covered in essence a web page. I'm going to start with the first part, which is what is mitosis, and just give you a brief overview. You can see that we start by giving the student clear goals. Here we say you will be able to describe the purpose of mitosis and each of its phases when you're done with this particular module. We'll go on and start to provide explanatory text and some images. Everything that we do is Section 508 compliant. Here you see an example of an image that has an alt tag that can be read by screen readers for students with print disabilities. But then the key idea here is that very quickly, as soon as the student's done a little bit of reading, they're going to stop and they're going to do something. In this case, we ask them one of 25 different question types that we support in the platform. Here we're asking them about the role of mitosis in the overall cell cycle, and they're able to type their response here. This is a simple submit and compare question where they're given immediate feedback, which is the response of an expert, and then they're asked some questions asking them to compare their response to that of the expert to drive some of the learning that takes place. They go on and read a little bit more, and then you see an example of active learning where we take what would typically be an image in a textbook that might be labeled and say this is the structure of a cell prepared for mitosis. In this case, we're going to have the student actively build that image for us. And so we ask them to read the instructions on the right, go ahead and start, and they're going ahead and they're building a cell that's prepared for mitosis. So in this case, I made a mistake. It tells me I need to go back and put an inner circle. So I do that. And then I can place the centrioles. Again, if I put them in the wrong place, I get some feedback on the right, and I get a chance to try it again. And so it's just a simple example of taking something that's typically a passive experience for the student and turning it into a more active experience so that they benefit from that. As soon as they're done, they're able to then continue on. And this is really in many ways the heart of our learning experience. We have embedded over 1,000 formative practice questions throughout a typical course experience for students. So they've done that image, and now after they complete that activity, they answer the following questions. These are simple multiple choice questions. It's a 3-part question, and importantly, whenever the student selects an incorrect response, in this case chromosomes, we're giving them a very targeted piece of feedback to that particular mistake. to try to help them learn from that mistake and make this practice activity a learning experience. If they get an answer correct, we reinforce the correct answer and allow them to move on to the next question. We also want to make sure that students who are working on their own time don't spend much time in a stuck state. And so we also embed hints in every single problem that we provide for a student, and in many cases we provide multi-level hints that range in progress from hints that nudge the student a little bit to hints that move them closer and closer to the response if they remain stuck. So in this case, you see that we have a hint, we have another hint available, and then there's yet a third level of hint available for this particular student. So that gives you a quick example of what the learning experience looks like for a student on a single page.